Moving on to question 6 here. Now we have a question on a probability generating function for a discrete random variable x, and the function we've got is k ln bracket 2 over 2 minus t. So pretty standard here. We just got to find the exact value of k for the first mark, then part B asks us to find the exact value of the variance, and then part C just asks us to find a probability. So let's jump straight into this. It's pretty nice as a question here. So for the exact value of k, well, you've just got to be aware of the fact that if you sub 1 in here for t into this generating function, this whole function will be equal to 1. So what we're saying here is that g of 1 makes the whole function equal to 1. So can we use this now? Of course we can. We can use this now to obtain the value for k. So what we're saying is that k ln, now where there's a t, we put 1 in, so that'd be 2 over 2 minus 1, so that'd be, this is the same now as ln of 2 minus ln 2 minus t. But if you put t in there, this becomes ln of 1, which is equal to 0. So all we get left with is ln of 2. So this becomes k ln 2 is equal to 1. Okay, so k ln 2 is equal to 1. Now to get k, just got to divide through by ln 2. So therefore k is equal to 1 over ln 2. Okay, and there we have it. So that's the value for k just for the first mark. Okay, so part B, 7 marks. There's quite a lot, so I'm going to clear this so we've got hopefully enough room. So for part B, we've got to find the exact value of the var of x, or the variance. Okay, so how do we do this? Well, the formula for the variance here is given as this. So you've got to work out derivatives for this. So it'll be g prime prime. Oh, sorry, let me just ignore that. So this will be when you sub in 1, right? So we always sub in 1 for the variance of x, plus the first derivative at 1 as well, so g prime of 1, and then we minus this off a squared, so it's minus g prime of 1 all squared. Okay, that's the formula we need. So for us to be able to do this, we're going to have to differentiate this. So if I write the function over here and I'll write the derivatives. So g, if I just write it as g, well that's going to be equal to k lots of ln 2 minus ln 2 minus t. Okay, so I'm splitting these ln's up here. And I know we have what the value of k is. We have the exact value, where k is 1 over ln 2. But for now, I'm just going to keep it in terms of k, and then at the end, I'll sub my k value. Okay, so you can do it here at the beginning, but I think it just makes it easier to do it at the very end. So doing this now, differentiating this, so g prime, if I call it g prime of t just for now, well, how do we get this? So we're going to have to differentiate this function here. Well, ln 2, that'll just differentiate as 0, minus ln, bracket 2 minus t. So 2 minus t, the derivative of that will be minus 1 times the minus on the outside. So what I'm going to get here is, it'll be k lots, because we need the k still, of 1 over 2 minus t. 1 over 2 minus t. Okay, and we can rewrite this and it'll make it easier because we've got to differentiate this again. This is the same as k over 2 minus t, and again, just one little step further, this will be k lots of 2 minus t to the power of minus 1. Okay, so we've got to differentiate this again. Hopefully this is relatively straightforward. So g prime prime of t, what will that be? Okay, so just differentiate this here now. So differentiating this using chain rule, you're going to get k lots of 2 minus t to the minus 2. Okay, so that's the second derivative. So we've got the second derivative, we've got the first derivative, we've got everything we need now for this. Now all we've got to do is plug in t equals 1. So therefore, variance of x, well that'll be equal to k lots of 2 minus 1 to the minus, so what we're doing first, we're doing the second derivative first, so that was this one here, so it's going to be k lots of 2 minus 1, so 2 minus 1 to the minus 2, plus this g prime of x, well my g prime of x is this, so plus k lots of 2 minus 1 again to the minus 1, and then finally we're going to minus this off, so it's going to be minus k lots 2 minus 1 to the minus 1 all squared. Okay, well 2 minus 1 to the minus 2, that's just going to be 1, so I'm going to get k Same again here, 2 to the minus 2 minus 1 to the power of minus 1, that'll just be 1. I'm going to get another plus k there. And if this is plus k, this is the same thing, just squared, and I'm minusing it, so it's going to be minus k squared. But we know, up here now, that k is equal to 1 over ln 2. So just plugging in my k now, it's going to be equal to 1 over ln 2 plus 1 over ln 2. Finally, minus 1 over ln 2 squared. Like so. And there we have it. So that's part B fully complete for the 7 marks. And now finally, we've just got to find the probability that x equals to 3. Well, for this here now, the probability that x equals to 3, well, we've just worked up to the second derivative. So we're going to need the third derivative. So I'll just write down the second derivative again. Well, that was equal to k lots 2 minus t to the minus 2. Okay, but we need g prime 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 of t. And once we've got this third derivative, we can use the coefficient of t cubed using the Maclaurin series. And remember the Maclaurin series is about the point 0. Okay, about 0. So if it's about 0, that means we're going to have to sub in t equals 0 for our final probability. Okay, so we need now g prime prime of 0. Okay, so doing all this now, the derivative will be, if I do it over here just so I've got enough room, it's going to be k lots of 2 over t minus 2 minus t, so let me just undo that, sorry, 2 minus t, 2 over bracket 2 minus t all cubed, and then writing that in terms of k, well k is 1 over ln 2, so 1 over ln 2 times 2 over 2 minus t cubed when t is 0. Well, what would I get when t is 0? So it's going to be 2 over 2 cubed, so it's going to be 2 over 8 or 1 over 4, so I'm going to get 1 ln 2 times 1 over 4, so I'm going to get 1 over 4 ln 2. Okay, so 1 over 4 ln 2. So all I've got to do now is plug this in using the Maclaurin series. And remember, the coefficient of t cubed for this case would be the third derivative, so g prime 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 at 0. The denominator here will be 3 factorial because it's the third term. Okay, so 3 factorial. Well, what's this going to be? Well, we know this already. That's 1 over 4 ln 2. 1 over 4 ln 2. And this is divided by 3 factorial, so that's 3 times 2 times 1, which is equal to 6. And if you've got 1 over 4 ln 2 divided by 6, that'll simplify to 1 over 24 ln 2. And then just put this into your calculator and get a value. So if I did this to 3 significant figures, you get 0.0601 to 3 significant figures. And there we have it, that's question 6, fully complete.